All right, last section for Unit 6, Section 6.4, arc length and area of a circular sector. This is really a bonus section. I'm not assessing you on this particular learning target directly. It is something more that you might end up seeing later on in your math career, so I want you to be familiar with it. We're not going to spend a whole lot of class time talking about it, though it might show up as part of a highly proficient question and answer on an assessment. So, thank you for watching this. I'm going to try to make this worth your time, and I'm going to try to make this as short as possible. So, length of a circular sector, or length of a circular arc, is what we're going to start with. An arc is what we call a part of the distance around the circle. Not the entire distance around the circle, just part of it. So, the arc length is part of the circumference of the circle. So the formula to find the arc length is S equals R times theta. S is the arc length. R is the radius of the circle. And then theta is the angle in radians made by the arc. And that's measured at the center of the circle. So where's this formula coming from? Basically, it's part of the circumference, right? The circumference of the circle, C, equals 2 pi times r. 2 pi, we know that's the number of radians around the circle. So 2 pi times the radius. This formula, instead of 2 pi, it's whatever angle we have for the particular section of the circle. So instead of 2 pi, we just have the angle, theta, times the radius. Find the length of an arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. Subtends just means that's the part that we're looking at, basically. Central angle of 30 degrees. Well, theta is in radians, so let's convert this. 30 degrees is pi over 6 radians. And now let's just plug into our formula. The arc length equals the radius times theta. 10 pi over 6 meters, 5 pi over 3 meters. That's literally it. Okay. Now, I could also ask you, a central angle theta in a circle of radius 4 meters is subtended by an arc of length 6 meters. Find the measurement of theta. All right. Well, the S equals R theta. So the arc length is 6 meters. The radius is 4 meters, and I want to solve for theta. So theta is 6 over 4, or 3 over 2, and that's the measure in radians. That's it. Again, I'm not really testing you directly on this, but you might see questions show up as part of other questions for a 4 on some of our existing learning targets. So try examples 3 and 4 on your own. Based on what you just saw, it really shouldn't take you too long. And then we'll move on and talk about the last topic, the area of a circular sector. So a sector is a portion of the circle. So that means the area of a circular sector is part of the area of the circle. So area is going to be r squared times theta over 2. And again, that's really coming from the formula for the area of the triangle, or of a circle, is pi r squared. And then we're looking at just a portion of the circle. And we can talk about where that comes from in class as well. But A is the area of a circular sector. R is again the radius of the circle. And then theta is the angle in radians again of the circular sector. So find the area of a sector of a circle with central angle 60 degrees if the radius of the circle is 3 meters. 60 degrees, let's convert that to radians right away, pi over 3. And now let's plug into our area formula. So area equals r squared times theta. all over 2. That's 9 times pi over 3 all over 2. 3 pi over 2 meters squared. That's it. Try example 6 on your own. But otherwise, there's really not much else to say about this, other than that, again, I'm not testing you directly, but you might see this show up in more challenging problems on some assessments. So come to me if you have questions. We're going to briefly discuss this in class, probably spend another 5 minutes, 10 minutes on it. But otherwise, have a great day. Thank you so much.